Good morning.
Morning. How's it going?
It's going okay, but I just cannot submit my lab to you. But we'll talk about that tomorrow. My report. But
Okay.
I'm just trying to see how incorporate. I ain't computer good with moving stuff in computers, but I'll figure it out before the night over with.
Okay. So,
Also, Miss Vitas, did you get my bonus $5 email to you?
I did.
Okay, just want to make sure.
Yep, I sure did. Let's do more. Okay. All right. I think we have enough people. Go ahead and get started. Okay, so we have, remember, we're only doing part one. You guys do part two, you get more bonus points. And the only thing I need to add is maybe some more stoichiometry problems, and that's it. So, okay, we finished reviewing. Until when? Let me see. Okay, we've done all of that. We did that. We do all of this. Yeah, that too. We have balance. There we go. This is where we stop, right? Part 4. Or did we do this yet?
No, we haven't done that yet.
Okay. All right. Yeah, I didn't think we did. I was like, wait, no, that was the other class. Okay. So we're going to do this part. I said, I'm only going to do 4 of these. And the rest are yours. Okay. So for this one, the very first thing to do is do the Lewis structure. So I'm going to do that. And then I'm going to erase it because, you know, I don't need the space, but we can annotate from there. So, okay. So let's do, let's see, which ones do we want to do? We want to do this one, these 4, okay? All right, so the first one I'm gonna do is NO2 cation. So remember, first you gotta do the tally. You got 1 nitrogen in group 5, plus you have 2 oxygens times 8, right? So that's, times 6. That's 12. And then when you add, this is 17, but you have a positive charge, so you subtract 1. That gives you 16. Next thing you do is you put them, you subtract the bonds, you get 12. Now see, when you get 12, you can readily see that oxygens is the only ones that are going to have any dots. So since you have 12, but you really need 16, you would really need 16. Then you've got to do 2 double bonds, right? One here. Oops. I changed that too soon. One here and one here. And then after that, you do your now. You should have a total of 12 electrons used. In addition to the 4, so you have a total of 16, right? So that's correct. The last thing to do is to do your brackets, and that is your Lewis structure right there. Okay. Looking at that, I'm gonna type the rest of it. Okay. Yeah, we're gonna. Okay, you can see that this is an A right? Because you got one central atom bonded to two different. There are no lone pairs around the central atom. So the electron pair geometry is going to be linear, right? Molecular geometry is also linear. The bond angle is going to be 180. What forces are we going to have? Well, first of all, it's nonpolar. So that right there tells me that all I have is London dispersion forces. And we could also induce an ion dipole because of one thing. We are charged, right? Do we have any resonance structures? No. We do not have any because we have double bond, but we have two. So they can't move around, can they? There's no other place they can go. All right, so let me undo all of that. So if you were to make this fluid structure, that would go there, but I can't draw it that small with my finger to fit it in there. So you guys do that part, okay? All right, so I'm just gonna clear that. And just, okay. Hold on a minute. Okay, there we go. Now, the next one we're doing is, it moved on me. It's the PO4, right? It's supposed to be there, but I might as well undo those two because they're in the wrong places. Okay, so the next one is the PO4. All right, so to do that one, we have one phosphorus, and he's in group 5 also. 5. We have 4 oxygens at 6 each. That's 24. That gives us 29, right? Plus we have a -3. In this case, you add. That gives us 32. When you make your lines, your bonds, right? You can subtract 8. That gives us a total of 4. And it is actually how many we need because oxygen needs 6 around each, and there are 4. So and that's that. And then you need, since it is a charged molecule, the last thing to do is this, right? Okay. And that is it. That is your whole entire Lewis structure. Okay. Now to fill it out, we would say we're going to look at it and we say, okay, that is an AB4, right? Because you have a central atom bonded to 4 different things, which makes this a tetrahedral. Molecular geometry is also tetrahedral because it doesn't change. It means our bond angle is 109.5. Is it polar? No, it's not. It's non-polar. Oops. That means our London dispersion again and ion dipole. So it can induce that due to it being charged. Hydro, what happened with the trough? There we go. Any resonance structures? No. No double bonds, no resonance structures, right? Okay, so let's clear that. We have the next one, which is SeO2. Okay, selenium. Okay, what did I do with my periodic table? There it is, I see it. Okay. Selenium. I think it's in group. I haven't done this in no, it's not. Selenium's in group 6. Group 6. Okay, so we start the tally with that one. Group 6. So we got 1. And then we have 3 oxygens. I mean 2 oxygens. I'm looking at the wrong one. Doing that one. We got 2 oxygens. So 12 more. No charge, right? So a total of 18. Okay. We need to do though, right? Subtract 4. This is 14. 14 is not enough for selenium and oxygen both. So we are going to need a double bond on one of these because we have enough for selenium to have 1 lone pair, but that's it. So we're going to make 1 double bond. And then I'm going to distribute the rest of these. One's going to go there. Now, let's see if we ended up with 18, then we're good. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 2 is 18. So that's good. That's the correct Lewis structure. Now, could it not also be this? Right? It could. Okay, so now we know what we can write in. All right, let's see. Lewis structure shows us this is an AB2E, right? You see that? Because you got 2 things bonded, but 1 electron pair, which makes this, when you first started, this is 3 things, so it's a trigonal planar. But the official shape is bent. And the angle is going to be less than 120. It is going to be polar because it has a lone pair. And that's going to make it have London dispersion forces. No ion dipole because it's not charged, but a dipole for sure. And that's it. Now, as far as resonance structures, you can put 2 because there's 2, right? 1, 2. And that's it. That's that one. Now the last one is CHCl3. Okay, let's do the math again. We have 4 from carbon, 1 from hydrogen, and 21, because it's 7 each, right, from chlorine. Adding them all up, you get 26. Now, if you put them, you would know that carbon's in the middle because it's the least electronegative of the ones that can be in the middle. Plus, there's only one. Hydrogen can never be in the middle, so you put hydrogen here. You got 3 chlorines going around. And now that we've done that, we used 8 for a total of how many? 18, right? Okay. So now hydrogen doesn't need more than 2, remember? So all of the dots are around chlorine. Okay. And there's your Lewis structure. And that's exactly 18 dots. So let's look at it. What are we? Well, we are an AB4, right? Which means we are tetrahedral both times. Our bond angle is 109.5. Are we polar? In this case, yes, we are. Normally, we wouldn't be because we don't have, what do you call them, around, no lone pairs around, but there's 2 criteria. The other criterion is that we don't have a dipole because all our forces need to be canceling. Well, this one, chlorine is more electronegative, right? I'm on the blue, okay. Yeah, so chlorine is gonna pull this way. That's your net force. And this one's gonna go this way. These 2 are gonna cancel. This one's gonna pull this way. That one's not. Because this one actually also pulls that way. So adding them up, you're gonna have a net dipole going that way, the way that I drew it, okay? Which means that you are polar. You have polarity. Since you have polarity, what do we have here? Well, let's see. We have London dispersion, of course. We're not charged, so we just have dipole. And we do have hydrogen, but it's not bonded, like right here, for example, to oxygen. You see that? That would make it polar. This one wasn't polar because it's not polar to begin with. So in order for you to have hydrogen bonding, the molecule has to be polar. And do we have any resonance structures? No. And that's it. Okay. That's the whole thing. Okay, let's clear all these drawings. Now, for the next one, it says to rank the intermolecular force from weakest to strongest. Okay, so the weakest is this one, no doubt. That's the weakest of all. Then we would have, it's somewhere between ion dipole, and I'm gonna put it first. I'll put it first. But that's gonna be, and there is no, you can't do the something or equal, but what I'm gonna do is I'm gonna try to do it like that. Hold on. I think I can. If I just underline it, let me see if that works. Ah, that did work. Okay, cool. And then the next one would be dipole, right? And then the last, or the strongest, oops, strongest is hydrogen bonding. And these are your intermolecular forces ranked. These can be, this one can be that way, or it can be the opposite. I mean, it could be even weaker. I don't know. It just depends on the molecules. But these right here, right, these two can be pretty much equal at times. So we could say that this is iffy. They could be equal, they could be less, it could be more. It doesn't matter. It's all of it. Okay. Now, for balancing equations, first of all, let's figure out who they are. Okay. Look at what's going on. Strontium and oxygen are becoming one thing. So this right here is a synthesis, right? I'm just gonna call it S for synthesis. The next one, you have a hydrocarbon with oxygen becoming carbon dioxide and water. This is combustion. Next one we have, that is a double displacement. Oopsie dee no. Sorry, come on down. That's a double displacement. This one is a decomposition. Another double. And the last one, single. Okay. Now that we know what they are, we can try to balance. All right. In order to balance them, remember, we look at the most complicated one first, which happens to be this one right here, right? We're looking at that one. And we're thinking, okay, so as you can see, oops, sorry, I let someone in and all this stuff came back clear. Okay. All right, so we can see we need a 2 because we have 2 oxygens, so we need a 2 right here. I'm gonna make this a different color. Great, I make it red. Okay. So 2. I said red and it didn't go red, did it? Okay. Come on. It's not gonna go there, that's why. This is the one I needed. Okay. So we have 2. Now we need a 2 here, right? Because we don't have enough of those. Oh, come on, stay red. Oh my God, it doesn't stay red. Okay. That's just so that you see it came from somewhere else. Now that's balanced. The next one, well, we normally would look at this and determine if it's even or not, but we have an extra set of oxygens. So we can actually do it like that too. But in this case, actually, we do not have an extra hydrogen. So we do need to do that. Looking at it and saying, oh yeah, this is the one. Okay, so we're gonna do a 6 right there because we have 12, right? 12 right here. Okay, then we have a 6 in the carbon, so we need a 6 right here, don't we? Okay. And if you look, 6, the first 6 gives me 6 oxygens, right? That second one, let me write these down. Okay, that first oxygen, so 6 times 1 is 6, and 6 times 2 is 12, gives me a total of 18, right? Okay, which means that we need how many oxygens? Well, we have 18, We have 6 already here. So we need to subtract those 6 to figure out what goes here. And that gives me 12, no? So there's another 6 that needs to go there. Okay, so let's put the 6 in there. And that's where that goes. Just want the 6 in right. I even clicked it, but it didn't do it. Okay. And there you go. By the way, this is a combustion reaction, but it's also, I don't know if you can see it, but this is cellular respiration. You know, when you do sugar breaking up in oxygen into carbon dioxide and water, that's what that is. Good. So let's clear that. Okay. Next one, we're looking at it and we say, okay, this one's going to be more complicated. So you got to look at both of two things you got to look at. The potassiums, which you notice there's not enough of them here, right? Because this is the most complicated. So we're focusing on this guy right here. Yeah, there we go. That's what we're focusing on. We can really see that we need a 3 right there, right? But look at this though. If we put a 3 right there, we have 3 and 3 is 6, right? So we need a 3 there. Because you have 3 times 1 is 3 plus 3 more is 6. So that means we need 3 hydrogens on this side. 6 hydrogens on that side. And now let's see if the oxygen's balanced. Oxygens, here we have 3. Over here we have 3. So yes, it did. That's it. It's balanced. Okay. So we needed a 3 there. Come on. Give me my color. And a 3 there. There. Perfect. Now, over here, you can see the one to concentrate on would be the water, right? Because it's the one that's the most complicated. So we look at that one and we say, okay, what is different on the other side? The hydrogen. No, the oxygen is. So we need a 2 here because it's only 1 on this side, which means we're going to need a 2 in front of this one also because now we have 4. And now everyone is balanced. You see that? Okay, for this one, what you need to look at more, obviously, is this guy, right? This would be the one I would concentrate on because it's got the most atoms. And look through and say, okay, look, I have 2 of these. You see that? Only have 1 right here. So we're definitely going to need a 2 in front of this one. Gotta have that 2 because that makes 2 irons. 2 irons right there. Now we're balanced there. Now what's not balanced is the HCO3s. And we need 3 in front of this, right? Because that makes that 6. Because see, here's 2 times 3 is 6, and here 3 times 2 is 6. Okay? So the next thing is to check your magnesiums. Obviously, they're not balanced, right? So we need a 3 in front of that one also. Now your magnesiums are balanced, your seleniums are already balanced, and your irons are balanced too. So that's it. And where I didn't put anything, you know, that 1 that you sometimes have to put in your programs would need to go there, but since we're doing it the way we're doing it, we don't really need to. Okay, actually this reaction would not happen. Looking at it, this would not happen. Bromine is below. Yep, bromine is below chlorine. Anyway, it doesn't matter. If this reaction happened, it would go like that. But this won't happen officially because bromine is below chlorine and it would never replace it. Okay, let's just say chlorine here, bromine there, then. But it doesn't matter right now. Okay, so who do we look at that's more complicated? Well, it doesn't matter, you take your pick. It's either chlorine or bromine. So let's just do this one. Okay, looking at that one, I can see I have one potassium, that's balanced, but we have two bromines, don't we? So we need a 2 there. Okay, that one's balanced. But now we need 2 on this one. Oh, wait a minute. See, we should have looked. We do need 2 on this one too. So we're going to need a 2 everywhere, aren't we? A 2 there. Yeah. And that was not where the bromine went, by the way. I screwed up on that one. That's not the 2 there. I don't know why I put it there. I meant to put it here. Okay, there you go. And that should do it. It should be now balanced. I don't know why I put the 2 over here. That's so wrong. Okay, and we're done. All right, so that part is finished. Next one is mole conversions. Okay, here's where you convert moles to mass and particles as indicated. Okay, the first one is giving us, this one I'm gonna have to write down like this. So what we know is that we have 36.5 grams, right, of sodium sulfate. So sodium sulfate, okay? And we're gonna convert that to moles. First thing to do is to get the molar mass. So for that one, we're gonna have 2 sodiums at 22.99. So let's do that molar mass. Plus, gonna have 1 sulfur at 32.07. Plus, we're gonna have 4 oxygens at 16 apiece, right? Okay, and I would put 0, 0, but I think I don't fit. Oh, actually I do, never mind. Let me erase that part then, because I do fit. I didn't think I did. Ah, see? 2 zeros, there we go. That's supposed to be 16. All right, so when we do the math, which I need to get my calculator. When we do the math, we get right here, let's see. Okay, so it is 2 times 22.99 plus 32.07 plus 4 times 16. And that gives me 142. So we know that for every mole, we have 142.05 grams of sodium sulfate. For 1 mole, right? They asked us to change it to moles, so we're done. Okay, we didn't need this last part we did not need. Okay, so all we need to do is divide. So it's 36.5 divided by 142.05. And that gives me the number of moles, which is, we need 3 sig figs, so we need 0.257 moles of sodium. That's that one. Okay. Got that? Have to have molar mass. Because molar mass, when you do it, is 142.05, right? Grams per mole. And that's what we did here. We did grams per mole. Now, we did grams on the bottom because that needs to happen right there, since what we wanted was moles. All right. So we're going to go ahead and write down the answer right here. I'm going to actually type it in, so that way we can just keep going for the next one. Okay, so it's 0.257 moles. Let me clear everybody else. All right, so I'm gonna do C next. So I've done A, I'm gonna do C. How much do 2.8 moles of silver nitrate weigh? Okay, so now we have the opposite, right? We have a backwards one. So we need to say 2.8 moles of silver nitrate. Silver nitrate. Okay, we need more mass because we're changing it to grams. So in order to do that, we say we have 1 silver. 107.67 or 87, I can't tell. What do you see on your periodic table? Do you see a 67 or an 87? Okay, I'm seeing it better now. It's 87. Okay, so it's 107.87. So that's your first one. Plus the nitrogen, right, at 14.01. Plus 3 times 16 for the hydrogens. Okay, see what that gives us. That's 107.87 plus 14.01 plus 3 times 16 close equals. That's 169.88 grams per mole. And this time the grams need to go on top, right? Again, and the moles need to go on the bottom because we want grams. Okay, so now we need to multiply that number times the number of moles, 2.8. And that gives us only 2 sig figs. So you have to say 480, even though it says 475. This is actually what I got, 0.66. Okay, but sig figs wise, we have to cut it at 2, right? Remember how we do that. We cut it at 2, but then this is large enough to make that go to 8. And then we just need 480 grams of HNO4. Not 3, sorry. All right, so the answer here, we need to type it in, is 480. That's with sig figs grams. All right, let's clear all of that. Okay, the next one, oops. Sorry, put in the wrong one. Need to cut it. Put it where it belongs. There we go. The next one is E. So E says 4.5 grams of aluminum sulfide. Okay. It says sulfide, not sulfate. I just realized now. So it's even less, so it's S3, okay? Contain this many particles of aluminum sulfide, okay? So in this case, we gotta go to moles first. So 1 mole would be here, and grams would go here. So guess what? Yes, molar mass again. This time we only have 2 things. We have 3 aluminums at 2698 and 2 sulfurs at 32.07. Oh, sorry, backwards. Did I do? I sure did. I did that backwards. Sorry. That should be 2. That should be 3. Okay, once you add it, let's see what I get. 2 times 26.98 close parentheses plus 3 times 32.07 close parentheses equals 150.17 grams per mole. Okay, so the bottom here needs 150.17, right? All right, now, is this all we want? No, that's not what they asked us for. They asked us how many particles. So now we need Avogadro's number. 6.2 times 10 to the 23rd particles or atoms of aluminum sulfide. Okay. So we need to do the math, and we got 4.5 times 6.2 divided by 150.17. Okay, the answer for me is this 0.18, and we only have 2, so it's 19. Because it's 1857, so 19. We have just 2 sig figs times 10 to the 23rd. But remember, this needs to move up 1, which means we subtract 1, right? Right? Remember, increase, decrease. So in this case is 1.9 times 10 to the 22nd particles. Your answer for that one right there. I'm going to write that down. 1.9 times 10 to the 22nd particles. So I'm just gonna write this up. What's your answer? It's gonna make it red, that's all. Okay, and that's how you did it. You have to do molar mass a lot of times. Molar mass is like a necessity in these things. All right, we'll have one more. Now, we have a total of 7, I think. 1, 2, 3. No, it's 6. And I've done 3, so that's good enough. All right, so you need to okay, percent composition. Okay. Okay, once again, molar mass. Gotta do that big old molar mass. So first thing is we have 3 nickels times what? 60, 58.69. Then we have, as you can see, 2 phosphorus, right? Times 30.97, yeah. Plus 8 oxygens, right? Because 2 times 4 is 8, at 16. Plus we have 8 waters. And waters, we've done enough to know that it's 18.02, but if you don't know, you can do it right here. It's 1.01 times 2. That's 2.02, right? Plus 116 gives you 18.02. So that's the water. All right, now let's add it all up and see what the mass is. All right, it's going to be clear. Okay, so this is 3 times 58.69. Close it. And then plus 2 times 30.97 plus 8 times 16 plus 8 times 18.18. Okay, so the molar mass of this stuff is 510.17 grams per mole. Okay, so as you're looking at this, we have now to do each one. So percent, right, of nickel is going to be this, right? So it's going to be 3 times 58.69 divided by this, 510.7 times 100. That's going to give me my percentage. And we have to watch our sig fig, so we need 4. Okay, so let's go. So it's 3 times 58.69 divided by 510.17 times 100. That gives me 34.51% nickel. That's our first one, right? And yeah, it does have to keep going. So unfortunately, we're gonna have to erase part of this so that we can keep going. The next one will be percent phosphorus. That's gonna be the next part. So 2 times 30.97, right, divided by 510.17. That gives me times 100. And you know what you're doing here. So like I said, you just gotta put this number, which is 2 times 30.97, right? Divided by that number there, 510. Okay, so that gives me 12, and we can have 466 to 12.14%. And that would be phosphorus. Okay, let me erase all this other stuff. Actually, I can do it up here. Percent oxygen would be next. And that's going to be this part, right? 8 times 16 divided by 510.17. Okay, so clear that. 8 times 16 divided by 510.17 gives me 25.09. Well, don't forget the times 100. 25.09%. Sorry, oxygen. And then the last one, which is the water, I'm just going to do on top of this thing. So percent water is going to be this number, right? 8 times 15.02 divided by that same 510.17 times 100. Okay, so let's clear that. 18.02 times 8 divided by 510.17 gives me 28.26% water. Now, if we were to add all of these, this one, where did that one go? This one, and this one. We should get 100. Let's see. So 25.09 plus 28.26 plus 34.51 plus 12.14 gives me exactly 100. Okay, so it's correct if you add them all up. All right, so that's how you do percent composition. Okay, now you know. Now, said we would need to do a few more on stoichiometry, and I do have a couple right here that we can do. So let me clear these. You guys have it, right? Okay. And we're gonna do a couple stoichiometry problems, and then we'll be done for the whole semester. Okay, so moles of compounds. I don't need that. Yeah, there we go. I don't want a mole. I want stoichiometry. Hold on. No, that's ionic equations. We don't want that. No. Okay. The mole. Here we go. I'm just looking for some problems that I have here. Stoichiometry in here. These problems. Empirical and molecular formula. Nope. Oh, this is oh, there we go. Okay, here we go. Let's do this one. Okay, it says, well, first of all, it gives us an equation. I'm just gonna put all this out more. Oops. Just so we have a completely blank board. Okay, so it says, based on this equation that I'm about to type in, ammonium plus, oh, sorry, it's not sulfur, it's oxygen. Yield nitrogen monoxide plus water. So now, first thing to do is balance it, right? So looking at it, you can see that that is not going to balance against that unless we put a 2 here, right? Now we have 6, so we can put a 3 there, and we can put a 2 there, and that should have balanced us. Except we have 2 and 3 is 5. We cannot have half of one of those, so we need to double it, double it. See, this is what I was telling you. Sometimes, oops, no, I meant to erase it. Erase all of these because we just found out that we actually need to double it. Why is that? Because our nitrogens need to be doubled. I mean, our oxygens. Okay, so now 4 times 3 is 12, right? So 12, that's a 6 there. And this is a 4 right here. Now 4 nitrogens, 12 oxygen, 12 hydrogens from hydrogen. So the oxygen is what remains. This is 4 plus 6, which is equal to 10. Dividing it by 2, it gives me 5, you see? So there's our balanced equation. Okay, let me erase this. We don't need that. But we do need the balanced equation. Okay, according to that, it's asking us, it says, we have hold on. Okay. For 3.5 moles, oops, of ammonia, how many moles? No, yeah, we're just going with moles first. How many moles of this are we gonna get? Okay, so this is your question, right? This is where you started, okay? So in order to figure that out, you notice we have 4 to 4. So there would be 4 moles of NH3 for every 4 moles of NO. Okay, so that will cancel. So the answer is actually 3.5 moles. Again, that one was easy, wasn't it? Okay. Now, what if they had given us 17.8 grams of ammonia? And they asked us how many grams of NO are we going to get? Okay, so once again, we first need to do molar mass. And in this case, it's easy because it's 3 hydrogens, so that's 3.03. And nitrogen is 14.1. So 407. Okay. So back down here is 17.04, right? Let me clear that real quick. Okay. So that's 1 mole. That's grams. Oops. Grams. There we go. For 1 mole of ammonia. It's good to write the ammonia down because now you need to do your conversion versus 4 moles of ammonia. Give you 4 moles of NO. And the last thing to do is figure out NO. So that's 14.01 and 16, right? 30.01. Where do we put it? Put it on top. Why? Because 1 mole of NO has to go down here, you see. We need to locate where we need it because grams would cancel, moles would cancel, moles are going to cancel, and we need our grams up there, which was 30.01. Okay. Oops. I just put it here, grams of NO. All right. So now we multiply the top divided by the bottom. And you notice that the force, we can just cancel these, right? Because they're going to divide out. So all we need to do is start with 17.8, right? Times. The next thing is multiplying it times 30.01. That's your top. Then you're dividing it by 17.04. And that should give us our answer. Our answer is 31, and we only have 3 sig figs, so it's 31.3 grams of NO. That's what you're gonna make, all right? I'm gonna do one more. And then after that, we're done. All right, let's clear these, because we're gonna have a totally different equation. Okay, so for the next one, we're gonna have an equation that sounds like this. It says, next one, grams to grams. We'll do a mass to mass, mass to mole. Okay, here we go. Mole to mass. Okay, so this is your equation that they gave you. CO2 plus H2O yields okay, so we need to balance it. Obviously, we're looking at this one first, right? Because that's the most complicated. We can see that there are 12 hydrogens. So we need a 6 right there. There are also 6 carbons, so we need a 6 right there. And that gives us 12 plus 6 equals 18. 18 that you're going to subtract 6 from, right? Because you had 6 already here. Plus what's left? Well, what's left is 12. So you need a 6 there. There you go. Okay, so let's clear that. That's our eraser. Right. It says, a question that we have is this. How many grams of glucose, that's the one underlined, are produced? So we have grams, grams of glucose That's the question, right? This is our question. Are produced when 24 moles of carbon dioxide react. Okay, so this is what we know, 24.0 moles. Yeah, that's what it says, 24.0 moles of CO2. Okay, so first thing to do, it's already in moles, so we don't have to convert that part. But we do need to do one thing. We need to do the molar ratio, 6:1. So there are 6 moles of CO2 for every 1 mole of glucose, which is C6H12O6. Now, next, now we need the molar mass. 1 mole of C6H12O6. 6 weighs what? Well, let's find out. We got 2 times 12.01 plus 12 times 1.01 plus 6 times 16. That's our molar mass of glucose. Let's see what it is. A long one. Okay. 2 times 12.01, close it, plus, why did I put 2? That should be 6. I knew there's something weird here. Okay, sorry. I know why I put 2. That should be 6. Okay. So I'm going to change it on mine to 1.6. There we go. So it's 12.01 times 12 times 1.01 plus 1 more is 6 again, right? Times 16.00. That gives us 180.18 grams per mole. Okay, that goes up here. See, grams per mole. All right, so what we do now is multiply that, which is on top, 24 times 180.18 divided by 6. And that gives us our answer, which is by sig figs is 721 grams of C2. I mean C2, C6, that's what happens, H12O2. 6, there you go. That's the one. And that 6 is a little bit, because I almost made it a 2. There we go. Okay, so there's your answer, 721 grams. All right. Now, let's do one more with gram to gram, which is going to take 2 molar masses. Let's do a simpler one, so it's not so, yeah, these two are good. Okay, so let's clear that. And this is our equation. We have sodium hydroxide that is reacting with sulfuric acid, which is going to make us sodium sulfite plus water. Okay, now let's balance. Let's see. Well, definitely not balanced because we have 1 extra hydrogen. Actually, no. Yeah, we do. We have 1 extra hydrogen. So this side is even, so we need probably a 2 right here. Okay, that gives us 2 there, so we need a 2 there. And that gives us 2, and 2 is 4, that's correct. And 2 more. Yep, that did it. That's all it needed. Just needed a 2 right there. Okay. Next question. It says, how many grams of sodium hydroxide? So this is the question right here, right? Are going to react with 50 grams of sulfuric acid. That's where we start, you see? Okay, so we need to do 50 grams of H2SO4 and doing that really fast. That's 2.02 plus 32.07 plus 16 times 4 is what? I think 64. Am I right? I think that's right. So you add it and you get 908 98.09. So that goes below here. 98.09 grams of H2SO4 in 1 mole, right? Of H2SO4. It's like I said, it looks repetitive writing it like this, but it's not. It helps you because the quantity tells you what to do next. Okay, so the next part is the molar ratio. Okay, so there's 1, right? Say 1 mole of H2SO4 for every 2 moles of sodium hydroxide. Now we need the molar mass of that. Let me do it real fast. So you got 1 sodium at 22.99 plus 16 plus 1.1. It's going to be 40, exactly. Okay, so down here, we have 1 mole, right? And it goes mole to mole. So 1 mole of NaOH. See, this is why I told you this helps you. For every 40 grams of NaOH. Okay, now let's clear this bottom thing here. Okay, so let's do the math. We just multiply all of the top things, divide them by the bottom things. So we got 40 times 2 times 50, right? 0.0, everything is there. All right, that's 4,000 divided by 98.09. And that gives me, because all the bottoms are ones, if you look, the answer is, 40.77, but we have 3 sig figs, so 40.8 grams of NaOH. There you go. And that is what I got. So that's your stoichiometry problems for the day. Do you want me to do another one or did you get enough? Okay, I guess we're done. This is it. We're finished. You are now ready to take your exams, your final. Make sure you do it by when? By the, what do I have it set for? I don't know. Let me clear all this and let's go back. Let's see, let's go back to, oops, to mouse. And go back here. Just close this. And just minimize it maybe. Yeah. Extend my session. It always does that. Okay, fine. It's timed out. I got you. We're just gonna go back here. Yeah, see? I knew I'd have to sign back in. All right. For this part, we are going to connect. That's what I was trying to check. Is when, oh, did I pass it? Yes, I did. Ah, I saw it coming through. There it is. Oh, not that. Not that one. No, sorry, wrong one. I meant to click the red part, but my finger went on the bottom one. Okay, there we go. All right, so your everything is set to close on the same day, and that is on the 10th. Okay, the 10th. Now your final exam, it says until the 6th. I don't know why it says that. Oh, I know why. Because some of you are graduating and you need to have it by then. But actually, the ones that are graduating, by the way, you need to let me know if you're graduating so I can get your stuff ready. And I mean it, like right now. Any of you, just chat. Do it through the chat. If you're graduating, I need to know right now. Okay, Gabby, I got you. Okay. Thank you, ma'am. So that means this is applicable to you right here. This final exam has to be taken by the 6th. No, actually before the 6th, because I have to give grades by the 6th. So you have to do it by the 5th. I'm gonna actually remind you that you need to do it by this 5th. Because midnight, because I have to put grades in on that day. I probably won't get to it till like the middle of the day. But if I were you, I'd have it done by the 5th, if I could. Okay? Not right now, no. Let me see. I would have to look on, and we need to. Actually, I haven't synced the rest of the grades yet. So I would need to do a sync right now of your stuff. I'm just gonna sync everybody. It doesn't matter if you haven't done it. I'm just gonna sync everybody's stuff. So I don't want to drop an assignment here. I want to sync everybody. Okay, so if I say sync list, that's just all that's never synced. See, the ones that were last synced here, I can redo because a lot of you haven't done them yet. But the ones before that, that was already done. See, it says the reason it's yellow is because you still have time to do it, right? But I can sync whatever there is there. It doesn't mean that this is the final sync. It just means that I'm syncing pretty much every single assignment right now. Okay, that's everybody. Takes a little while to sync, but there we go. I'm gonna go ahead and sync it. Okay. All right, so go back. I've added most of them except for the last two, I think. So I'll add them probably today. If I have time today, I will. All right, the syncing is gonna take a little while, but I can message you and let you know. Okay. right. So we're done for the day. Mhm.
Miss Diggs, what did you say about part 2 of the
Oh, on the, yeah, hold on, let me share again. All right. Let me see if I can. Well, maybe not.
what
Mm-mm.
did you want us to do with part 2 of the thing?
Yeah, hold on, let me show you what. Okay. Part 2, right here. It's a second part of
Mm-hmm.
the review, and that one's all yours. So if you turn that one in, plus the one I gave you, completed, you're gonna get up to 25 bonus points.
Okay, and how much of our grade is the final?
20%,
20%. Okay.
yes.
And when do we need to turn in these
Somebody's
two?
already turned in one.
Mm.
I'm sorry, when?
Yeah.
Okay, that one says November. No, I haven't opened that one yet. You need to do it by, I think this one has it though. Let me check. Yeah, May 11th. See it right there?
Yes, ma'am. Okay.
That's you guys that aren't graduating. The ones that are, has to be sooner, by the 5th, okay?
Okay.
All right, that's it.
So we need to do part 1 and part 2 for the extra credit?
Yes, well, depending on how many bonus points you want. This one's 10, this one's 15.
15. Oh, okay. Cool.
You need to finish this together.
Okay.
Yeah, 20.
Thank you.
Mhm. You're welcome. That's that. Anybody else?
After all this, when will the final grades be posted?
That is going to happen. I have to have grades in, if I'm not mistaken, by the 13th. Let me look. I don't want to say something wrong. Hold on. I have to look. I always look at the calendar because that's what I go by. Calendar's under here, right there. Okay. All right. So grades are due. Yep. See, 13th. So by then, I will have them ready. And for the graduates, I have to have them by the 6th, 4 p.m. by the 6th. So I have to do those. But there's a lot less of them. So, but I still have to get them done by then. So for you all, as long as you have them ready by when? Well, yeah, by the 11th, like it says, that'll be good enough for me because I can work on transferring those grades that need to be transferred. And I always check them too, make sure that they all synced, so it takes a little time. I do a grade sync, but not always do they sync. So I have to go back and check. But that's it. We're done. So I am gonna open that last one. I didn't realize it wasn't open, but it says May 11th, so I'm gonna do that here shortly. All right, ladies, you take care. And if you need me, I'll be there tomorrow. Remember, office hours, 10 to 12 and 2 to 4. Okay, bye.